give you a thumbs up.
All right. Hello, Internet. I'm back with you.
This guy.
We've just used some pronouns. We haven't actually said our names yet, so we'll leave you guessing.
I'll start. So my name is Brett Musser. I work for Edge Wallet, and I am the head of business development and content here, and I'm joined by my partner in crime, William Swanson, our chief architect, CTO extraordinaire. How you doing
Not
today?
technically the CTO.
You are, but to me you are. To me you are. How you doing today, William?
Good, good. I'm looking forward to answering some questions here.
Nice. Yeah, and it's a beautiful day in San Diego, beautiful summer. I actually just got back, and the team just got back from, or a couple of us got back from Toronto. We were at the Untraceable Blockchain Conference, and it was actually a really good conference. Had a lot of great discussions with users or some of our partners. Anthem Gold Herc was there, and they were actually one of the lead sponsors there. And they do some, they have a platform for, not only they have a gold-backed crypto coin, and they also have a supply chain application that they're working on as well. So it was good to see them. We also, another partner, Shapeshift, was there, so it's always good to see that team and what they're up to. Also saw, I kind of veering off, but another title sponsor that was pretty cool was a mining operation called Pluton Mining that's going to be mining out of California using solar power. Yeah, very, I'd say a pretty sexy project.
Well, we have
very
some solar
interesting.
out here. We have some sun.
Yeah, California in certain spots is like the Saudi Arabia of, I guess, solar radiation, because there's certain spots in California where you get, 8 hours of sunlight, and it's one of the you
No
get very
clouds.
very large concentrations of radiation compared to other places on Earth. So the Pluton Mining Group is definitely taking advantage of that, and they were telling me that they're going to be able to source power for like a cent.
Wow, that's a pretty good
unit,
price.
yeah, exactly.
Because
And
normally in California you think, oh shoot, we have
you're
some of the
8-9
most-
cents.
Yeah, we have very
at
expensive
least.
power out here.
Yeah, and they're going to be they own the land. They're going to have their own panels, and they're going to be taking excess supply from the grid, because there's a lot of energy out there that we waste daily because it can't be consumed.
Well,
And-
right. I mean, you have a thing like a nuclear power plant that's generating power 24/7 at much the same level. When it's nighttime and everyone's asleep, all that power is
Yeah.
wasted. But then in the daytime, it's being sucked down and then there's nothing left.
And what's interesting is that proof of work mining for any coin, any of these networks are perfect customers for electricity generation, because one of the unique things about electricity compared to other products is you can't really store it. If you make chairs and no one buys it, well, you can still store it and kind of sell it later.
Right.
Maybe food's in that category, but you can still refrigerate it. We know how to preserve food.
Well,
Electricity
you have
needs
a week
to be
or so for food.
electricity needs to be
Instant.
So you want 24/7 demand. And if you look at the history of electricity, it was bootstrapped by commercial generation. Big industrialists, needed a lot of power
To run
24/7.
plants.
And then they basically subsidized retail. If we just had retail electricity, the utilities never would have made it, because we just use a few lights here or there.
Right.
And it's just not enough to sustain a big operation like that.
Well, I mean, the big thing is you run your toaster once and then you're done. And so
Yeah.
it's like this load of toasting and then it's like nothing.
Yeah, and you pay a little bit for it, but basically the industrialists and 24/7 demanders are subsidizing retail use.
There's a
And-
funny story about England, actually.
Yeah.
So in England, they love tea, right? So anytime a big soccer match finishes, the electricity grid has to anticipate millions of tea kettles coming online. And so it's this big scramble for the electricity operator. Like they've got France lined up on ready to go.
What
Okay.
timeline was this?
This happens now.
Oh,
Like
it's
every
still?
time the soccer match finishes, the electricity grid has to respond instantly as millions of kettles turn on in England.
Yeah, I just
It's a giant problem for them.
I think it's all. I mean, proof of work mining is a huge opportunity for utilities if and some of them are aware of the opportunity. You have a 24/7 client that you don't need to move to; it moves to you. All you have to
Right.
do is ship in miners. Because before, a utility might have a commercial relationship, but they'd have to build it right next to the industrial plant,
Right.
Because if it's too far away, you're going to lose 80% of your.
Well, I can
electricity.
imagine a British miner who, when the tea kettles turn on, switches off their equipment for a few
Yes.
minutes to let the grid react, and they're cool like losing a few minutes of proof of work, and the
For
grid
sure.
now can just keep running at a constant rate. They've replaced their miners with their, so a flexible load like that is actually very valuable.
Yeah, I'm really fascinated in how proof of work mining is going to transform our whole electric grid, like globally, not just in the United States. And yeah, it was good to talk to the guys from Pluton Mining.
Well, they're not
and
going
what
to
they're
participate because they're on solar anyway.
doing. Yeah. What else? Oh, I also it was to give a little or give a little color on who was there that I thought was interesting in Toronto. I do see a little more interest in NFTs. So there was a few non-fungible tokens.
So
Which
things like trading cards and crypto.
Exactly. I saw some groups there that were they're starting to build and really see the unique value proposition of NFTs, not just for digital like collectibles, but turning like an SPV, so some type of financial or corporate entity into a non-fungible token.
So what's an SPV?
Special purpose vehicle.
Oh,
It's
okay.
it's like I guess a financial legal fiction, so to speak, that corporations can set up, and they can, and there's groups trying to tokenize that, and they think NFTs will be best suited for that, for whatever reason. And then there was actually some more OTC trading desks that I haven't seen before at conferences. Like there's few, but there was definitely a lot there. People are trying to get in the OTC business.
So when you
and
talk about
cover
OTC,
whales.
are you talking about like, I want to buy $1 million worth of Bitcoin, can you help me out? Are we talking
Yes.
about more like consumer level?
No. Yeah, these are big buys, big sells that they don't want kind of recorded on exchanges. You know, they want that kind of direct relationship, and they want to move a lot of money, and they're willing to pay for it.
Right.
So I guess those are the kind of the groups that stood out there, and the conference was really well run, and it was in Toronto, Canada, which I haven't been to in like a decade, and it was great. Beautiful city, kind of a smaller New York, nicer New York, because it's Canadians, they're nicer. The New Yorkers, not so much, but New York is fun. Toronto's fun, and I think that was it for the conference. And Paul, I don't know if you saw Paul, but he was at the Decentralized Dance Party going crazy. He
No,
was
I did
like,
not.
you got to see his tweets. I'll show you later. Peter was there. He saw him. He was going wild, and it was good energy, good times, good people, and a successful conference for Edge. So a little update there. Now, I guess one of the things we want to kind of transition to.
This is the Edge Q&A podcast.
Yeah.
So we thought, well, we got some beginner questions that keep coming in, so maybe we hit
Yeah,
some of
we're
those.
going to cover some questions that a lot of people ask us in support or over time. So, and I'm going to kind of pose these to William. I got them on my phone here. Let's see. So, what's a common one? All right. So, William, could someone just try brute forcing private keys? Wouldn't you find someone's private key by doing that for a long period of time eventually?
Yes, the answer is yes.
The answer is yes. Eventually, yes.
Yeah, but
So what is the time?
Well, that's the question: is what is this long period of time we're talking about? So in cryptography, this is going to get a little technical, but it's cool. It's not that hard to understand.
Mm-hmm.
We have everything we do is based on the idea that I'm hiding something somewhere. So I have some number that you're never going to guess, and that's what controls my Bitcoin or my encryption or whatever. But you could always try guessing. Right? There's nothing that stops you from just trying every possible combination until you find the one that works.
Mm-hmm.
So we have this notion of difficulty. How many bits of security does this cryptographic operation provide? And the basic concept of that is how many guesses do you need to make before you find it? And it's actually kind of counterintuitive, because if I have 8 bits of security, if you know how computers work, then you know that a bit doubles every time you add another bit. You double the number of possibilities. So if I have 8 bits of
Because each bit has 2 states.
it can be on or off, right? So that doubles the number of things you have to try. So if I have 8-bit security, that means you have to try 256 things, and you've guaranteed guessed my key, and you've got my money. So 8-bit security is not considered safe because you can do it trivially in seconds.
Mm-hmm.
Your typical 4-digit PIN to get into anything, we're talking to maybe 10 bits of security, 15 bits of security, depending on So that's not particularly good security either. But the counterintuitive thing is, as the bits get bigger, the growth kind of skyrockets.
It gets out of hand for.
So you get 32 bits is 4 billion possibilities. That's like garage door opener clickers, which is still considered easy to brute force because a computer can try 1 billion things in a second. You get to 64 bits. Now you're talking about a data center, a big giant data center, running for a couple years. Levels of effort to try every possible possibility.
Yeah, yeah. To get to your one private key that they might not even know
Right.
how much is on it.
Exactly.
Yeah.
Bitcoin private keys are 256 bits of security. Okay, so what we're talking about is we went 32 to like data center. Now we're talking about that 4 more times. So it's actually the number of atoms in the universe, the number of atoms in the entire visible, all the stars.
I just love that phrase. You know, I feel so safe when you say things like that.
All stars in space and the sun. Like you think about how many atoms are in like a little cubic centimeter of water. It's like a stupidly huge number you can't even think about. Then we're talking about the whole freaking universe. That's about the scale of 2 to the 256 bits. So there's no way that a computer inside the universe, itself made out of matter, could go through all 200, 2 to the 256.
It has its own physical limitations, like
Yeah.
light itself.
Yeah, light
Right,
itself.
yeah.
You could not do the computation in the universe that is that big.
So, let's get to so this, I think this segues into an even sexier question that people love, quantum computing.
Right.
So how does that, say there is, we see there's an existence or it's confirmed there is a quantum computer out there.
Right.
What does that mean? Or
So-
what does that mean for private keys? What does that mean for Bitcoin, cryptography in general?
So what we're talking about here is just pure brute force. I'm just going to try
What we have right now.
every single possible key, just one by one after the other, to look for all the money on them. And that process is not feasible because it's just the numbers are too big. Now, it turns out if you're clever about it, you're not just going one by one, but you're actually using the mathematical structure of the signature algorithm.
Okay.
That you actually only have 128 bits of security for a 256-bit key. Like you lose half your bits.
Oh, because of what? I miss.
There's something called the birthday paradox.
Okay.
And this applies generally to many different things.
Uh-huh.
And the idea is every time, suppose I have 2 people in a room and I want to see, like, do they share a birthday? Well, I have a chance that my birthday happens to be yours, so I've got 1 chance, right?
Okay. Yeah.
Add another person to the room. Now I've got 2 chances. But not only that, do I have 2 chances? You have 2 chances. You can also match with him too. So as we add people to this group, the number of chances that we would have the same birthday actually goes up, not person by person, but actually squared. So like I double the number of people, I'm actually being 4 times more likely to have a shared birthday.
Gotcha.
And so that means that if I get to 256 bits and I'm looking for collisions or things that happen to be the same as each other, that I actually only have to try 2 to the 128 possibilities instead of the full 256 because that's doubling effect is actually kind of reducing the space I have to search.
Gotcha.
It's increasing my odds of success as an attacker. So by just keeping track of some data as I'm doing this search, I'm actually like saving myself a massive amount of work. So Bitcoin's down to 128 bits. Now, other forms of mathematical structure in the signature algorithm are vulnerable to quantum computers, meaning that if a quantum computer existed with a sufficiently big calculation unit, that it could exploit those mathematical relationships that are part of elliptic curve cryptography and just reduce it from having to do 128 bits worth of work, which is still an insane amount that no human could ever do, to like, oh, I'll get it done in a few seconds, because it's like going down the back, taking a different path than just brute force, one by one by one.
And how would Bitcoin or other cryptocurrencies that are using elliptic curve cryptography, how do we respond to that?
So if a quantum computer gets on the horizon as being a practical thing that's going to exist, we're going to have to change the math that Bitcoin is built on. And the good news is new math does exist.
Yeah.
People have been working on this for years. There's actually a really old signature scheme called Lamport signatures from, 40 years ago, that is perfectly quantum resistant. Completely 100% quantum resistant, no problem.
So we already have mathematical functions that are theoretically
The
quantum
problem with Lamport signatures is they're freaking huge.
Okay, that's not good for scaling.
Yeah, so you want a signature. It's like you've got to do 1 million operations on your CPU, or several million, and the signature is like 8 kilobytes instead of like 32 bytes or 64 bytes. So it's like massively huge, and then huge amounts of work on top of that, and it's just not practical.
Gotcha.
But if we faced with quantum computers and the extinction of cryptocurrency as we know it, heck yeah, we'll use Lamport signatures or any of the new hotness that's coming out that's shrinking this stuff down even better.
Yeah, because it's more important to preserve the wealth, and I guess I would take the trade-off of scaling for preserving wealth, right? If,
Right,
if
right,
you have an existential threat, and we're like, okay, we'll put scaling on a back
Yeah.
burner right now.
I'm not saying that Landport signatures are the
Or-
only
No,
technology
you're
out there.
just bringing it as an example
It's been around
it's
for
already
40
there.
years. It's
Yeah.
well understood. It's not sketchy. There are newer cryptography things that people are coming up with all the time that are so much smaller and faster than this. But the thing is, they're new, right? So we have
Yeah.
no idea. Like, it hasn't been vetted. It hasn't been battle hardened to know that this is really secure.
So that brings up the question of, okay, say there is a quantum computer, we need to move to these quantum resistant algorithms, and the question becomes, how do you do it? Does it have to be a hard fork? Could it be a soft fork? What would be the preferred implementation? And I know everyone has their own, like, what do you think would be the best way to implement something like that? It's a big signature change.
I mean, one way to do it is just to do a soft fork. And a soft fork is basically saying we're going to tighten the rules in a way that previously they were loose, now they're tight, right?
Yeah.
So we're just going to say no transactions are permitted going forward using the old signature algorithm.
Okay.
It's just not allowed.
Without kicking the old nodes off, or
Right.
the old.
We're just not. If you have money in an old signature format, that's just not allowed to move it.
Yeah.
But what we can do is we can then issue new coins, and you can soft fork new coins into the system by using like a sidechain or like SegWit kind of created this separate space. And what we can do is we can issue new coins one-to-one with the old coins, and to prove that you own the old coins. Good news is Satoshi was smart, and he didn't just have the public key, which you can brute force and find the private key straight away using a quantum computer. He actually had a hash in there. Hashes are resistant to quantum computers.
Yeah, there's no mathematical function there to exploit.
Well,
Is that the
there
reason?
is a structure and a function, but quantum computers can only use something called Grover's algorithm.
Okay.
And Grover's algorithm gives you the same speed up as you would get from the birthday paradox anyway.
Okay.
So it actually isn't like worse than it is now. I don't know if that makes sense.
A little bit.
Yeah, so I have this hash function that's 256 bits. The birthday paradox means it's really only giving me 128 bits of security.
Mhm.
But Grover's
Which is good.
algorithm reduces it to 128 bits of security anyway. So it's like, it's no better than the birthday paradox.
Gotcha.
So in very technical terms, it takes you from second pre-image resistance to just collision resistance. So it's not.
So in this case, would a hard fork be unnecessary and unwanted?
So if we wanted to do it as a soft fork, say BTC. BTC does not want to hard fork the network.
They love their soft
They
forks.
love their soft forks, right? So this is a way that they could do it. Now, if I was on a chain that I controlled and I had like the centralized authority to make a hard fork,
Yeah.
then maybe we would choose that as an alternative, right? Monero loves their hard forks, and that's a great system for them, so they could just do it that way.
Gotcha.
So yeah, a soft fork way would be to issue new coins, one-to-one with the old coins. You can't move the old coins anymore because they're all using the bad crypto. But if you can show that you can solve that hash by having the information on the other side of it, which you need in order to move a Bitcoin today, that kind of gives the assurance that yes, this is your coin and therefore you can claim it on the new side where you're using this new signature scheme. So there's a way to do it. It's just a
Yeah.
little confusing, and you probably have all the wallet software has an interface like upgrade my coins, claims them, and then you have the new coin.
So I have a little mining question
Okay.
for you. So, question is, would miners shut down after rewards get too small? I guess they're asking in the future, thus making a 51% attack easier.
Yes.
Okay. Why is
Well, okay, so when we say shut down, as long as there's any money to be had, people are going to go get it, right? So if you remove the block rewards as the thing that the miners are making money off of, the only thing left are transaction fees.
that? So fast forward, we're in 2130.
We're 2130, right?
The
Like 100
inflation is gone.
There's no more new Bitcoins being minted, right? So every Bitcoin on Earth has been created. There's no more to be created. Miners aren't getting paid in freshly created Bitcoin. So what are they getting paid in? They're getting paid in transaction fees, period. That's all that's left. So then the question is that enough to keep them running? And the answer is, well, I mean, Bitcoin collects how many dollars in transaction fees a day? Maybe a couple thousand? I don't know. I haven't researched this question ahead of time. But say it's a few $1,000s. Well, then we'll get a few $1,000s worth of proof of work on our financial system, and that's probably not enough to really secure it.
Yeah, we'll see. I mean, well, I think people will be willing to pay if it's valuable enough.
Right. And so maybe there's one scenario which the Lightning Network kind of proponents like, which is Bitcoin transactions become super rare and also super expensive. So if a Bitcoin transaction costs $100 and you're doing a few, tens of thousands of those a day, well, that's fine. We can handle that. I think it was be like what, like 100,000? I think it's about 100,000 transactions a day, $100 a piece. That's like $1 million, or a couple $1 million worth of proof of work. It's fine. We can survive with $10 million worth of proof of work probably. And that means that if you're moving Bitcoin on chain, that's a $100 mining fee. 90% of the transactions, 99% will be on the Lightning Network and cheap and free.
Gotcha. Yeah, so I guess the proponents of Lightning think everyone will probably be on that second layer by then. And like they often say, Bitcoin will be a transfer settlement assurance network.
Right.
That you don't, it would be too expensive to use as an individual user.
Right.
Yeah, and everyone's just anchored to it.
Well, the other way you could go is the Bitcoin Cash sort of side. So this is like the other side of the holy war, right?
Yep.
And the Bitcoin Cash side is like, no, we're going to do everything on chain. There are how many people in the world? Let's say there's 10 billion people in the world. It's the future, right? The population growth is going to continue, but not so much. Maybe 10 billion people. Everybody does, 10 transactions a day times 10 billion. That's 100 billion transactions per day. Everybody pays a couple cents. Well, there you go. They've got $1 billion a day reward pool going to the miners for their effort in validating
and
this chain.
instead of having instead of it being super expensive for a transaction on the base chain, it's actually cheap, and it'll be okay, or it'll add up because there's a lot of
Because
people
there's a lot of
making
people
those
making a lot
transactions.
of transactions, right? So that's the goal, is like, we'll just scale everything on chain. Now, the technology needed to handle that,
Yeah.
you're talking about 10 terabytes a day. If we just, we assume every transaction is about 100 bytes, and then this is really back of the envelope math, right? Like that times 100 billion people or 100 billion transactions, then you're getting to 10 terabytes of data a day, which you can do. I mean, you can transfer that much internet over the internet today, and we're not even talking about 100 years from now technology, but it's expensive. And so the question is, we've got $1 billion a day to pay the miners. The miners need these massive data centers with these huge storage systems and all this technology to handle the data volume. I guess with $10 billion a day, you could probably figure it out.
Yeah.
Or $1 billion a day, you could probably figure out how to make that technology work and still have a run system.
This question actually leads into our next one, which is, does a currency, does it need inflation to function? I would say no, it doesn't need inflation. It could be a part of your system. I personally think that what you need is enough units for everyone, and not only enough units, like more than enough units for everyone, but also granularity in pricing. So like having that Satoshi and being able to push that, like I guess those decimal places back is what's really important. And we don't really know because we've never had a currency. Like even gold has an inflation rate.
Right.
So we've never so there is nothing that anyone could say, or in my point, that they could have theories about it, but no one actually knows what the world will be like 100 years from now when Bitcoin has no inflation, or what would it be called? Is it called disinflation?
Well,
I don't even know.
There's
It's
really
zero
there's
inflation.
no
Right?
such thing, right? So
No such thing as what?
zero inflation or deflation, because coins are always going to be lost, right? If I make the mistake, I lose my phone, I drop it in the toilet, I don't have backups.
Oh, at that time, it'll definitely be a deflationary currency.
Yeah. So you're either creating new units more than you're losing new units, or even by a minute amount, you're always going to have one of those two scenarios in play. So the typical inflationary scenario, which we're so used to because we've lived our entire lives in this regime, is the government or somebody constantly produces fresh money out of thin air, just poof, more money. Or in the case of gold, they dig it out of the ground. So it's not thin air, it's thin dirt, but new money is being created and entering the system constantly. And with that, the expectation is that prices will slowly go up.
I would imagine.
Yeah. So because if there's twice as much money and the same number of apples, then it's going to take twice as many units of money to buy one apple or any kind of good that is not being increased in ever increasing quantities. Now, we've actually seen the opposite of that, computer technology. Because computers were going through Moore's law, they're having such this great acceleration, you could buy twice the computer for half the money because the technologies just got better in the meantime. So we actually saw what deflation looks like in a computer scenario.
I would say it's extremely positive.
Yeah, yeah. Think
Yeah.
about how that.
Well, yeah, I feel I don't know if there's a direct overlap, but when I kind of map inflation to entropy and deflation to reversals of entropy. And what I think a lot of human beings try to do is reverse the natural entropic processes of the universe. So I think a deflationary currency is kind of in that mode, and inflation is just like it's decaying like the rest of the world.
Right.
So I don't know if I don't know. I feel like it would be better for your currency to deflate, in my
I
opinion.
actually think that deflation, as in terms of money supply, actually encourages more moral behavior.
Explain. I agree with you largely on that.
Yeah. So what it is when you have cases of extreme inflation, like the Weimar Germany tragedy,
Yep.
where their money was just losing its value 10, 100x, it was just really a shame because you get paid and then a couple days later your money's literally worthless. That people became cheap. They just went out and they bought consumer goods as fast as they could because they just wanted to spend their money.
Sounds
right?
like the United States.
Yeah, and it drove this sort of very broken society, and there was a lot of just immorality and just as people were struggling just to survive.
It sounds like you're equating, or there's a lot of overlap between time preference and moral decision making.
Right.
Is that what you're getting at?
Yeah, like you're encouraged to do things that you wouldn't normally do just because you know that if you got to do that or nothing, so I might as well get something for my value if I can. So
Yeah.
you'll settle for really bad scenarios. So that is not a great system. But when you have a deflationary system, what that means is your money sitting is now becoming worth more and more and more over time. So that means your choice between buying a car today and buying a car tomorrow on debt, you're like, I'm going to wait because by tomorrow I don't even have to go into debt. My money's just going to be worth more sitting there. So I'll prefer to buy the car later. So it encourages thriftiness, frugality, buying quality goods that last. Because if I buy a car that I'm just going to have to throw away, or shoes that I'm going to have to throw away because they fell apart, why would I have wasted my money? I'd have rather kept the money in the bank for that time. So I'm going to go ahead and I'm going to buy the best shoes, the best. So you're buying, it's like kind of that quest for authenticity that people are having in this modern era. Like we want authentic goods. You'll start to see that come back. More handmade things of quality, things,
Things that last.
Things that last. More of a sustainable, just society, I think, will emerge from a deflationary.
So I think you brought a great point between I guess time preference and morality and moral decision making. So I think when you're in a consumerist mindset, you kind of put yourself in a scarcity mindset because in the present moment, it's true. It's kind of a zero-sum game if you're in the present, right? Only one can win and another can lose,
Right.
Only you can consume that product and no one else, or there's a limit to it.
Right.
Where if you extend the time scales or your, the time in which you're thinking about the world, you might, you might start have to coordinate with people, and defer consumption and maybe give it up to someone else in the present who needs it more than you.
Right.
And you'll be rewarded for that in the future.
Exactly.
Right. And I think that is a lot of moral calculation. Even if you're not, let's say you're not an empathetic or sympathetic person, if you're put into a context in which you're forced to think long term, I think that puts you in a position to make better moral decisions. You might not be, let's say the actor itself is a psychopath who doesn't really care, but if you put them in the right context, where
It's
it
aligning
becomes
incentives,
rational,
right? What becomes good
that's
for
why I
you
think,
is good for society.
aligning rational thought and incentives with the greater collective
Yeah.
is what you want. And I truly believe, like you said, a deflationary asset helps with that. Elongates people's time preference and their ability to think long term and get out of the scarcity mindset of the present.
Right.
Which is true, but it's not complete because I think there is an abundance out there, but you have to think kind of long term, and you can't just think myopically right now. I win, you lose.
Right.
I consume this, and you don't.
And when you think about it, even step back another level, like what does a deflationary money supply represent? It represents that my waiting, well, there's more goods to be had in the future. Like if I buy one apple with my money today, I can take that same money and buy 2 apples. So if we tend to look at things through the lens of money, but really reality is the thing that changes and money just kind of stays reflects that. So what that means is that in a deflationary society, you're seeing economic growth.
Mhm.
Because the money stayed the same, or maybe slightly smaller, but more people were making more apples.
Well, you at least have a floor
Yeah.
in which you can build off of. Because when I think of fiat from a social perspective, it's like everyone's in quicksand,
Mm-hmm.
right? And the best fiat out there, the US dollar, it just doesn't sink as fast.
Right.
So when they saw a strong dollar, and that's just a terrible foundation to build a civilization on
'Cause-
over any type of long time scale. But in the short term, you can juice things, and we have been doing that with bubble after
Right,
bubble. But is there any actual real economic growth? Like in
Yeah,
terms of
yeah.
like worker productivity
Exactly.
and like bare bones, like are we actually producing
Are we
and
digging more
are-
things out of the ground, or
and like you know
producing?
we've had a lot of innovation in information technology,
Mm-hmm.
which is kind of I guess a short term kind of thing, you know, short bursts of communication. But we haven't seen a lot of innovation in like flying
Right.
or a lot of the things that
And
allow a
what's
step
the
function.
classic image of back east, right? It's steel mills shutting down, or coal mines shutting, like all that big old infrastructure.
Yeah,
We're not
yeah.
like seeing new infrastructure coming in place. Like we're building.
We're sinking.
Yeah, you're sinking. Yeah.
That's a good way to put it. Let's see. Oh, let's talk about.
We're
We'll
almost
finish
out of
up on
time,
some
so-
Oh, are we out of time?
Yeah,
We
it's-
kind of are. All right. Well, yeah, we'll just leave it off there.
All right.
All right, guys. Well, we talked about hard money. We talked about Bitcoin, inflation, brute forcing private keys. Thanks for watching. We'll be on next Friday. If you have any questions, throw them our way, and we'll try to answer them as best as possible.
Remember, your keys, your coins.
Peace.